This is Don Brill again. It's now December of 2023. I made yet another version of the rice huller using the pinch rollers. This one, which is based off of the Stoltz boat trailer rollers. It's urethane, 90 durometers, and these worked great. Then we received some emails from people saying that they couldn't get these anymore. I checked with Stoltz. They no longer manufacture this. So I tried to come up with a solution, and one of them was using this polyurethane, smaller diameter roller that is also 90 durometer. It's there's a video on it showing this one. It's name of it is called Piranha. So this new one is the same concept. You have a drive that's got 12 teeth in it. You have another one here that's got 24 teeth. So this roller will go half the speed of this roller. The chain is kept quite loose because we have to allow this to move as the rice goes through it, especially if you start to overflow it. This block here was added because our chain is so loose, at times it would slip. We only have 2 to 3 teeth in contact, and that is the absolute minimum. Someone could take this roller here and move it up so that we have more teeth in contact, but you just slip this on there, it'll keep it in place. Let me just go around and see how that works. Talk about this side. So over here, this is our feed hopper. We have a chain here. These are number 35 chains. And of course, the sprockets in the chains have to match. This sprocket here is a tooth or two less than this one, so this will go a little bit slower than this wheel. This is our gap setting system. There's a spring, and then here is a nut that controls the gap. This controls the load. This is some foam. This is the ramp after the rice drops through. Comes down here. Here's a brush here and a brush here, which are just throwaway paint brushes that I've trimmed. And what they do is clear off the debris that gets stuck to our rollers via some static charge. In here is the 36 grit sandpaper. This is what's going to feed it. You'll see when it's operating how the rice comes over the top of this and drops down. There's usually a clear piece of plastic here so I can see what's going on, and also I would normally have a clear plastic here. So now we're going to run the huller, do 2 cups of rice, see what the results are. Then I'll take it apart, show you how to build the sides, and how to build the roller itself. We'll also have a list that's behind me here of the cost and all the parts. So now we'll put 2 cups of rice in. And we should come up with a total of 1 cup of rice. So as I start turning this, I'll lift my gate up, let the rice start to drop through. now we're facing this. So this right here is the flow rate that I think is the best. The key to our system is that we never overwhelm the roller. We get one layer of rice coming over the top, and that's all we want. Here's our results after the first pass, and I would say we're at 90%, which is amazing. I'll run it through again. This is the second pass. Here's the results after passing 2 cups of rice through the huller. This results are amazing. I didn't think it would do this well. So here's what was left. That's 99%. You'll never get better than that. Starting with 2 cups of patty, processing it twice. Here we are at our 1 cup. Here's the screenshot of the cast iron wheel. And right up here, I want to show you the difference between short and long grain rice. So this is the short grain rice after it's been hulled. This is it with the hull on it. This is the long grain with and without, and you can see the difference. This one is more like a ball, and it will drop through our separator where we just use holes in a steel plate, whereas these will not. Down here, this is the screenshot of the polyurethane sheet that you can also get on Amazon. This is the list of what you're going to need in order to build the hauler. This doesn't include the wood for the sides. Also doesn't include the throwaway paint brushes, which are probably $2 a piece. You have the caster wheels, the urethane sheeting. This is the epoxy that holds the shaft in place inside the wheel. This is the epoxy we use to attach the urethane. These are the shaft. These are from the big bearing store. And then this is the bearings that we use. These are inexpensive bearings, so they are not meant for high RPM, and luckily we're just doing maybe 30 RPM. And then we have the roller chain, the various sprockets, the idlers. Down here, this abrasive. These are those 1-inch sleeves, 36 grit. Then this is the 2-foot length of 1/8-inch walled aluminum. It's got 1 inch on each leg. Then these shaft collars here, this 30mm OD is important. We're gonna use 2 of these. Actually, we'll use all 4 of these, 2 on each one, to center the wheel and the shaft. This is the winch handle, and then you just have these various, this is the collar here that we're going to use to in the feed hopper, and then these prices down here are just what I guess these other pieces are going to cost. Also, we have a gentleman that is going to sponsor and maintain a website with more detailed instructions on how to build it. It's going to be at riceholler.org. The next part of this video shows building out the sides. But I don't give this dimension. So these are all 12 by 8 inches. Up here is a bracket that has slots in it to make it easier to align. These bearings all have set screws in them, and that sets the gap right at the bearing. But by putting this on, I've stabilized it. Same thing here. This bracket was on the top. I moved it from here down to here, lock this in, and then I could mount this brush on there. Again, I use the slots. These are handmade with a hacksaw. These feet, not critical in the dimension, they're probably an inch. And then I just drill a hole here and take a hacksaw, match to that, so that these are slots rather than holes, because it was easier to align. Now we'll just go to showing you how we built this out. In here, where this is, in the video I show lowering it down. If you just go straight down, it's going to give you another 1/4 inch up here in the hopper. Might help you with the volume of this, because it's pretty small. So here are the 4 sides. This is going to be the stationary. This is the side that moves. The location of this depends upon this. We need this gap in here between these two to allow the 2 rollers to hit. So you can see that I've done that. So you take a bearing, you determine the distance from here, put your bearing on, drill these holes, and then in the middle of this put the clearance hole for the shaft. So this was a 3/4 inch. So once you make one of these, and again, what you want to do is these pieces, in fact all 4 of them, should be identical. Especially the height up and then across here. So once you do one, you set this up, you just lay them on top of each other and you drill these holes. The holes on the lower one. Now when we go to do this one, it's the same thing. You can reuse this template if you'd like. You flip it over, you do this, and you drill these holes, and then you drill those holes. So all of these should be identical. That's your goal. So here's what your rollers look like. We've got to make sure we have that sticking out. We're below this edge here, in case we need to put something over the top. This height from here up, I made it higher just because I need this angle to drive material out. You could, in fact, if you had a permanent mount, you could put ramps this way so that it would drop into the middle there. So here, this is the side that's going to be moving. it doesn't get clamped to the base because it's going to slide. These are my 1/2-inch bolts. The way you set it up is you just eyeball it. You know that your chain's going to come up through here and down. So I try to keep the top of this below this ledge. Then it goes down, and then here I cut this slot that's a 1/2 inch. I drill a 1/2 inch hole here, 1/2 inch hole here, and then take a saw and cut out the notch. The one thing on these is to make sure that this is a 3-inch bolt that is threaded the entire way, and the measurement for the 3 inches is from the inside of the head. It doesn't include the bolt head itself. Let me just make sure that it's fully threaded. If you get one that's not fully threaded, you may not be able to clamp it tight on here without adding a bunch of washers. But fully threaded is your best way to go. Let's turn this guy around. So again, this is my clamping system where I cut slots, screw it together. Here's this brush. It does work. I would prefer this to be a little lower, so you might figure out how to take this brush and move it down here. On these with these rollers, this hub right here sticks out past this edge here, so I needed to take up that space. And what I happen to do is just take this 1/8 inch piece of wood here and attach it. That way I can do this, because our goal is to keep rice from falling in here. Another method would have been to put something over the top of this, but this is how I chose to do it. The other thing is to do it this way. It's nice that I have this gap back here. I don't have to worry about hitting anything. So this is the stationary side. I have these aluminum legs down here, 1 inch by 1 inch, 1/8 inch thick, where I cut a notch in each one. I have 4 of those, each on each side. And then I do have this top plate that goes up here also. That's how it looks. This is this ramp. This ramp is only attached on one side. Looks like that. This angle you'll determine to get it under. It has to be just under this other roller. So this roller would be like here. A wheel. And then this was this plate we used to take up the space because this hub is wider than our wheel itself. This is this brush idea. I actually cut the end of this brush so that it was shorter, a little stiffer, and surprisingly it does appear to work to keep the husk coming over. These are the parts that you're going to need that do not include the feed hopper. This is just for the pinch roller system itself. You're going to need this epoxy. This is what we use to lock this in. 1/2 inch shaft. This actually was not a drive shaft. This was just from the hardware store, 1/2 inch shaft, so it's pretty soft. You're going to need that. This epoxy. This is 5-minute epoxy. This is to glue these two together. Winch handle, shaft collars, In here are actually two shaft collars that were used to align this, and they are 30 millimeters in outside diameter. This is this aluminum 1/8 inch thick, 1 inch legs that I've cut out. Some more of this aluminum right angle, the 1 inch, 1/8 inch thick. This is for the setting the gap. These are the springs. Choose these springs because they come for 3D printers, but this 1/8 inch the bolt here will slide in it. So that's why we use that. You're going to need this nut right here that has the plastic insert, number 35 chain, 2 idlers, number 12 tooth sprocket for the 1/2 inch shaft, another one that's 24, 4 bearings for the 1/2 inch shaft. And then over here, this is the wood. There's 1, 2, 3, 4. There's 4 sides. These are pieces that we use to keep the husk from continuing around on the roller. This was the wood for the ramp, and then this is the base. Here's the hopper. I'll slowly take it apart. It's approximately 12 inches by 8 inches. These dimensions aren't critical. It can be shorter, it can be taller, it can be longer. These are the bearings. Got a screw right there. Got one wall. So you can see this right here is about 1/2 inch of the surface. So you want to try to make that 1/2 inch or a little greater. If it's too small, the rice will come over the top. It's pretty clear how I built this. This edge right here should be the midpoint of your shaft. So like that, with just enough clearance so that the rice doesn't fall in between it. I've got a couple of screws holding it in. It's not even attached on the other side. These are the screws that are holding this angled plate. For those of you not familiar with this, you hold this with a clamp, you draw some lines, hold this one, draw lines, and then you drill holes so you know where these screws go. This is my gate. Again, it's only screwed in on one side. I actually only used one screw there so that I could change the angle. And then this just has a slot with a screw in it so I can go up and down. The real key here is that once you make one of these sides, the other one needs to match it. So you lay it on top. Hopefully you can get your, of course the bottom here is most critical. So I've got the bearing here. I've drilled these holes, drilled this hole, put this over the top, and then you match your pattern. As I've said, I would move it down closer to this corner. Just line them up like that. So this was our feed rollers. These are sleeves, sandpaper sleeves for a drum sander. So this is a 1-inch diameter. These are shaft collars. They have a 1-inch diameter, so they're extremely convenient. If you want to make your own, you can take some belt sandpaper, cut it, and then epoxy it on here. But this is just very convenient. I just put it on, and as you saw, it works great in there for feeding the rice. So the number of teeth on these two, this one is 18 and it goes up here. This one was 15 and it's the one that attaches to the slower roller. I would suggest you do this. Have this one have more teeth than the one coming off the slow roller to slow down that feed system here. So if you're still watching this video, you're now going to see how we get our 1/2-inch shaft mounted in this wheel. I went with the 1/2-inch shaft because I could get these more robust bearings, again, pretty cheaply. I think they're like $6 to $10 a piece, instead of using these very small ones that are metric that we had to use for the piranha rollers. So what I did was, it just so happens that these metric collars match the ID here. So this is 30 millimeters. This ID on here is also 30 millimeters. So you'll see where I just drill this out by putting it in a vise. I don't clamp the vise down and let it just self-center itself and drill it out, put it on. We used this JB Weld adhesive in here. You just mix it up, put it on. The adhesive up here was the DevCon 5-minute epoxy. The 5-minute epoxy is because I have to hold it just hold it for 10 minutes in place. I'm not sure what's in the video. The videos are going to be a compilation over time, as I had to take things apart, put them back together. The key on your epoxy is to put the epoxy on as thin as you possibly can. I put it on pretty thick one time and it just made this really, really uneven. And then we always use our blocks to spin things and make sure they're nice and smooth. Idea is we're getting this concentric with this, and then the last section of the video will zoom in on this to show you how we did the gap setting. So now let's get to putting this together. This is our 1/2-inch shaft where I've drilled out these two. I put some Scotch tape on the shaft to allow me to tighten it down. Here's a notch that I made by grinding this in with my cutoff wheel. These bolts have been smoothed down, so now everything is even. I'm going to be using Scotch tape in order to get the diameter of this to match this internal diameter on these. Here's how I set up my rollers with the bearings prior to mounting, so that I know I want to have some out here because you don't know if you're going to use this in the end. So this is the side that's going to take the handle. So this is 9.5 inches long overall. Here's the wheel that's 5-inch diameter, is 2 inches wide, that we're going to use to make another rice roller design. Here's one that I've already finished. The first thing is you got to take these off. This is the roller bearings that are in here. Hopefully this will come off. And in here is a sleeve. So, turns out the outside diameter of this is 30 millimeters, and the inside diameter of this is almost 30 millimeters. It's a little bigger. So we're going to be putting these on and then putting a little bit of tape on these to make up for that gap. Okay, so now what I have is about 1/8 of an inch cavity right here, and 1/8 of an inch cavity here, and this is where we'll be putting on the epoxy, and that should bind all these together. But let me show you something first. So by taking a couple of two boards, putting them together, and then put them together like this, and then I drill out a 1/2 inch hole here with my Forstner bit. Then if I take this, put these together, and I spin it, I can put this on it, and then by spinning this can see how far off it is. And right now, once I got rid of the imperfections in the roller, I can spin this and I can see how out of round it is. So this is as good as it's going to get. We have a little bit, maybe a 64, no, not even a 64th. Very small movement of where it's out. And we're going to have to just accept that. The spring and the polyurethane will absorb that. So now I'm going to attach this polyurethane sheeting to our roller. I have a durometer measuring tool. This does your hardness. It's in the A scale, and when I put this on there, it gives me between 90 and 92 durometer, which is what we're looking for. So right there's 90. This one in 91, over here 91 again. So we know that 85 and 95 won't work, 85 being too soft and 95 being too hard. So we're going to cut this to our 2-inch width. By patiently adding and subtracting the Scotch tape, I'm able to get this to almost be perfect. So there's what you want the end result to be. I've put in my epoxy, so now it's locked in. So now this video is going to move into putting the urethane sheeting on the steel wheel. We just did the shaft, centering it. Initially, I put on one layer of this 1/8 inch thick 90 durometer urethane, but instead of getting 70 to 90% holding rate, I was getting 50%, sometimes 20%. I adjusted the gap, adjusted the chain tension, but I couldn't get good enough results, so it was very, very frustrating. The issue is that this 90 durometer, this 90 durometer, these both worked really well. The difference was that I have all of this 90 durometer urethane, all of this, but here I only had 1/8 of an inch. There is an understanding that once you penetrate 10% of a surface, the substrate, the underlying surface, starts to affect the surface above. So what I believe was happening, as it was being indented, the urethane was actually getting harder because it was adhered to this steel. When I did one of these on a wooden roller, it worked. I don't remember how well it worked. It was quite a while ago. So what I did was I then doubled up these layers, and you saw the results we got. We got exceptionally good results, except we have to do 2 layers. We use this 5-minute epoxy on it. The one thing I want you to say about using these epoxies is clean the surface with just dish soap to get rid of the release agent, and then I used 50 grit sandpaper to roughen up the surface as much as I could. This resists that. And then when you put this adhesive on, put it on, this is a putty knife, put it on as thin as you can. Initially I put it on pretty thick, thinking it'll just flow to being level. That did not occur. The other thing I tried was, I don't know if you can see this, brushable super glue. Initially it worked, and I was like, oh, all right, this will be easy. But it turned out after I hauled a couple of pounds of rice, it seemed to break down, and I was able to just separate it out by peeling it out. I think in the video I'll be showing about how this is a shear, not so much peel, and that's why these are going to work. So in the video we're going to be putting the adhesive on, then the reason we're using the 5-minute epoxy is that it sets so quickly. What you can do is you're going to put on one layer, then you literally have to hold it for 10 minutes in position. That would be the minimum. So you can go back and forth between the 2 rollers. You got to just hold it, and that does take time, and it is annoying. So now we'll just show you what we've got on attaching these. So this is some stainless steel that I've roughened up the surface. This is our urethane sheeting that I also roughened up that surface. and I use the 5-minute epoxy. So I just want to show you the strength of the epoxy. So this is shear as I pull on it, and I'm pulling as hard as I can. But then when I do the peel, you're going to see that it may or may not come off. I'm believing it'll just come up, which it does. But because, and it sticks to the urethane before it sticks to this. Now maybe you could treat this more and it would stick. But the key is that as long as we're in shear, we'll be okay with this adhesive. It's that peel strength that it just doesn't have. So now I'm going to put the urethane onto our roller. Earlier I tried to do the urethane without cutting it, so I did all of this, and it turned out I could not hold it down, so areas came up and that became problematic. I had to scrape all the epoxy off, and now I'm going to redo it. You want to get this epoxy on here as thin as possible. A couple of things. When I first did the shaft concentric to the outside of the roller, I wasn't careful enough, and it turns out use the tape, which is this just simple Scotch tape, take up the space, and be very careful and put it on so that you get this absolutely concentric when you spin it. Make yourself one of these holders, and then you'll see that when you spin it, you can get it perfectly in the middle. I tried using the steel stick after I put the tape on and pushed it in, but it actually moved the shaft a bit and made it not concentric to each other. So instead, use either the 5-minute epoxy. This is what I would prefer. This, once it cures, it's rock solid. So you have 5 minutes of time here if you use the DevCon 5-minute epoxy. That's before it sets. So try and make sure you stir it for at least 2 minutes. And then I think it's 8 to 10 minutes when it will set. And then another couple hours for full cure. When I put this epoxy on the first time, I put it on casually and didn't try to make it as thin as possible. So when you're doing this, put it on as thin as you can. And of course this surface, I treated it with some solvent, some acetone or mineral spirits to get rid of the releasing agent that would have been on the urethane when it was made. And so now I'm just going to spread this out as thin as I can. So I'm making this very thin. Last time I wasn't as careful and let it build up on the edges. So don't do that. Try to make it nice and even. So this looks pretty good. Let me do one more here. So now I'm going to just take this, put it on, and now I'll hold this for the 5 minutes, actually for 8 minutes. Then I'll have to do this 3 times. And so it's so thin you can't really even see the glue edge. And that is my goal. I'm going to try to match this with what I'd had before. Okay, just going to put this in. This down. Put it the other way. Okay, I'm sliding it a little bit. So if there was any cavities, it would fill it. So now I'm going to put this on, hold it for 10 minutes. So this is the roller after I just put on the urethane with that real thin layer of epoxy. And we're going to look at that gap. So there it got a little closer, a little wider right in this area. And now I'm going to remove any bumps the way you do that as I slide it in. And it's going to hit. There, just moved it out a bit, but that's not too bad. All right, let me remove some of the material. I now have 2 layers of the polyurethane on our steel roller. And if I spin this, it'll show the unevenness. So that's what we're going to work with. You can see that some spots are closer, like right here. Well, we'll see how this does in the roller. So this is the final section of this video. We've gone over almost all of the parts. We want to go in detail into this gap setting. It's not as complicated as it looks. You've taken your aluminum right angle tool that was 1 inch by 1 inch. I've now drilled 4 holes in here because I really want to lock it into the 2 halves that are going to be moving. These springs will slide over the bolt. This is a number 8 bolt. They come sort of with a standard, I think, 32 threads per inch. Over here, this bolt here has a built-in lock washer, so this won't go loose. If you don't have that, you have to put in a lock washer. This is the nut that has the plastic insert on it, so it won't loosen while I'm working. Our aluminum has the notch in it, so this will sit here. And then this nut on the end is what we use to tighten it up, so it doesn't take that much compression. And that's just pretty straightforward. Another thing that I missed was that if you do make this on your own, you're going to have rough areas or something that might stick up. This is a quite rough file, not smooth, and this is what I use to remove the polyurethane. The last thing I didn't cover was the winch handle. So you buy your own or you can make your own. These come with this rectangle in it, and you can either take your 1/2-inch shaft and grind off a section so that it slides through here. The other idea that I used was I took a 1/2-inch bit, drilled a hole here, and then added these shaft collars, drilling holes through it and then clamping it like this. It's not very elegant, but then once you put it on, there's this set screw that you can use to lock this in. Those are just some ideas. Good luck with your project. I hope for the people that are growing rice with small volume, if the Piranha rollers are no longer available, then you may have to switch over to these. Good luck.